Welcome to Quest, the weekly inter-school science quiz brought to you by National Council of Science Museums and Doordarshan Kendra, Kolkata. We are back with 2 new schools, 6 new faces. But before going on to the schools, let me introduce to you Mr. G.S. Rautela, who will be conducting all the experiments. Welcome, sir. Mr. Rautela, I believe you are the director of the Nehru Science Center, Mumbai?
That's right, yeah.
Okay. Is this your first time in Calcutta?
No, I have been here earlier.
Okay.
But first time in this studio.
First time in. Introducing the teams to you. On my right is the J.C. Bose team, and you are?
Hello, I'm Devadip Shen from South Point High School.
I'm Shayan Chakraborty.
I'm Shyamindu Dasgupta.
And on my left is the C.V. Raman team.
Hello, I am Joyanta Shah from St. Xavier's College.
I'm Sheikh Wasim Raja.
I am Ayan Pal.
Okay, I wish both the teams the very best of luck. Before going further, let me explain the rules. They are fairly simple, the very same as in the previous episodes of this quiz. 7 questions in all, 4 are going to be direct. The first 4 will carry 20 points each. That's 2 questions for each team. Approximately 10 seconds to answer. If you get it right, then you get 20 points. If it passes to the other team, they pick up 10 points. If neither team answers the questions, they go into the audience. The last 3 questions of today's quiz will be on the buzzer. It's plus 20 and minus 10. More about the buzzer when we come to it. Meanwhile, let's get on to the very first experiment of today's episode. The first question is for the J.C. Bose team. That's the boys from South Point High School on the right. Mr. Rautela.
Well, I have 2 masses here. One is a little heavier than the other one, and they are tied by a thread. I put them around this rod, and if I allow in this position, the heavier pulls the smaller one. But when I stretch it horizontally at a little angle and drop it, see what happens. It winds up around the rod. Now you have to tell me what is the reason that the heavy ball cannot pull the smaller ball.
When the smaller ball comes down like this,
Yeah.
It has an angular velocity.
Yeah.
Because of that, it has a centrifugal force acting on it to the outside, which measures mv square by r.
Okay.
Now that force adds to the gravitational force when it is at the bottommost positions, and hence the sum of the centrifugal force and the gravitational force exceeds the weight of the other mass. So the other mass cannot pull it down.
Why does this wind up? That's you have to answer.
Why does this wind up?
Wind up the thread.
When it is already coming down, it has angular velocity, but as it has come down, its length has decreased a little.
Yeah.
So its moment of inertia in fact decreases. So its velocity in fact increases. So it winds up.
That's right. That's right. Let's give them some point. Thank you very much. I would like to add a little bit on this, which you didn't talk about, is when the thread radius reduces, as you said, the speed, rotational speed increases, but as it winds up, the frictional force between rod and the thread increases, and it increases exponentially.
Yes.
As a result, the heavier ball cannot pull the smaller ball. Thank you, brother. That's right.
Well done, Shayan. You pick up 20 points for your team. The next question will be for the C.V. Raman team. Welcome back. You're watching Quest. The scores at this stage: the J.C. Bose team has scored 20 points. That was on the very first question. And now, C.V. Raman team get their first question. Mr. Rautela.
Before I ask you the question, I would like to explain what the setup is. I have a funnel which has been truncated like a hopper, okay? And I have another funnel which has a long arm. What I'm going to do is, I put equal amount of sand in both these funnels together simultaneously. But before I do that, I have to ask you, the question is, or guess rather, which one will empty first, or will they empty together? And before I perform the experiment, I need a volunteer.
Do we have any volunteers in the audience? Plenty of volunteers. Everybody's volunteered. Yes, why don't you come up?
Okay.
Hold the mic. Face the camera. What's your name?
Well, my name is Debru Bhattacharya. I'm from the South Point School.
Okay, Debru.
Prabhu, I would like you to hold this cup under this smaller funnel so that it doesn't spill over. Okay? Now, watch me what I do. I will have to drop both together simultaneously so that there is no confusion. 1, 2, 3. So you have seen the funnel, which is like a hopper, truncated, takes much more time the funnel with a longer arm. Now the question is, why does it happen?
The sand is a granular substance, you
Yes.
know. When it falls to the truncated funnel, it comes through direct interaction with the air around it. So the air tries to resist its velocity downward, and it's but in case of the long arm, the sand, the granular sands, does not come direct contact with the air. So its velocity is not restricted so much by air, and hence the truncated one takes much more time.
Sorry, I couldn't award you the points for this. Rather, the question passes on to J.C. Bo's team.
In the truncated funnel,
Yeah.
we see that this sand falls in bursts. I mean, some sand falls, then it gets clogged for a minute amount of time, then some sands fall. This is because of bottlenecking effect at the mouth of the funnel.
What is bottlenecking effect?
When too many things try to come out of a small aperture suddenly, and in presence of another media in the outside, they tend to clog and block the neck. But in case of the other one, the sand falls in a streamlined fashion, that is, there is no bottlenecking. In fact, as the sand falls, there is a slight air cushion in between the sand and the walls of the funnel, and so the sand can fall very smoothly, and there is no bottlenecking because that neck is long enough to avoid bottlenecking.
Well, I am tempted to give them 10 points for the almost correct answer.
Thank you, sir.
But I would like to add a little bit to their answer so that it becomes much more clear to others. Is in this truncated funnel, when the air tries to rush from the top to fill up the small vacuum because of falling sand, it doesn't help the sand because it automatically falls. But in this case, when the air tries to rush, it smoothens the flow of particles, and the friction between sand particles is reduced. As a result, the motion is much easier, and that's why it takes much lesser time than this one. This is the technique normally used in chemical industries, where they call it fluidized beds. They move air through the particles so that the movement and reactions are much easier.
Good answer there, Shayon. Wasim, I'm afraid you had the wrong answer. So 30 points to the J.C. Bose team, and C.V. Raman team is yet to open their account. 30 points to the J.C. Bose team, C.V. Raman team yet to open their account. The third question in today's episode of Quest is for the J.C. Bose team. Mr. Rautela.
Well, the next question is, now I have two bottles connected by a tube, and one of the bottles filled with water, the other bottle doesn't have any water. But the water doesn't flow, there's no siphoning action takes place from this bottle to this. Now the question is, under what condition will the water flow to the next bottle?
If we open both the caps,
both the
then
caps.
only the water can flow freely from one to other.
Can you tell me why it doesn't happen with the one I open only one cap?
Because air pressure needs to be applied on that level also, on that water column also. Because if we in this case we have opened only one cap, so air is applying pressure through this hole on that water column from this side. So that water column does not fall down. But if we open that cap, then air will apply vertical pressure from the in the mouth of that bottle. Okay, so that pressure causes it to flow.
I would also like to add something.
Yeah.
We know that the pressure of air is equivalent to 30 feet of water. So that small amount of water cannot overcome the pressure air is delivering through this tube.
How much is that air pressure?
76 centimeters of mercury,
Yeah,
which is equivalent to 30 feet of water. So
That's
it
absolutely
cannot
right. They get 10 points. Let's also see that when I open this, now see the water goes up in this bottle. So what they said was right. because the water column pressure is much smaller than the atmospheric pressure. That's why it prevents it from flowing from this bottle to this bottle.
Well done, Debodeep. Well done, Shayan. Both of you answering in tandem. I wish I could have given you 10 points each, but you know you've picked up 20 points for your team. Your score is now 50 points. The next question is for the C.V. Raman team. $50 points to J.C. Bose's team. C.V. Raman team, you better do something and quick, because this is the last of the direct questions and it's for you.
Well, the next question for C.V. Raman team is, I have a jar and I'm burning a paper and pushing inside. And trying to close it. Question is, why does this glass stick to my palm? This portion they can do it.
When the paper burns, some oxygen is consumed there and carbon dioxide is produced. Now, so the volume inside decreases and
some water along with that is produced. The water which is produced inside will absorb the carbon dioxide, because carbon dioxide is well soluble in water. Hence, some vacuum is produced inside and inside pressure is less, and when something is pressed on that, it sticks.
Tell me, why does oxygen form? From where it form? Why does the water form here?
Water form because in that paper there is some something hydrocarbon is there, some amount of hydrogen and carbon. When the hydrogen burns in air, it produces water, and some carbon when burns.
Well, that's not the absolutely right, but their answer was correct to that extent that when there is a partial vacuum, when I'm burning this carbon dioxide hot, it goes away. As a result, partial vacuum is inside what they said, and that's why my hand, because the atmosphere from the top gets stuck to this glass jar. So I would give them 20 points for this answer. Nice attempt.
Well done, Wasim. You picked up 20 points for your team. $50 points to J.C. Bose's team, 20 points to the C.V. Raman team. The fifth question of today's episode. This one is on the buzzer. Let me explain to both teams. If you hit the buzzer, irrespective of whether the question's been asked or not, you've got to be ready with an answer. So it's plus 20 and minus 10 if you don't get it right. These questions do not pass to the other team, they'll go straight into the audience. Mr. Rautela.
The question is, you have been given a beaker with 2 straws, and I also have a glass with 2 straws. The question is, you are asked to take out 1 straw from this and put it outside, but the other end of the straw put in your mouth. But don't do anything. You have to suck and tell me what happens. Can you suck the water? You can't suck the water.
Yes,
now the
Shayan.
question is, you have to tell me why not.
Because when we are sucking, actually we are trying to create a partial vacuum within our mouth so that the atmospheric pressure pushes the water through the tube. But when we also have this inlet into our mouth, there is a free entry for atmospheric air to enter into our mouth. So we are unable to create that partial vacuum. So we cannot pull the water.
You are absolutely right. You get 25.
Shayan, let me ask you a question. Don't be afraid to answer it. Do you have a girlfriend?
No.
Have you tried the same thing during Valentine's Day?
No.
Not tried it. Mr. Rautela?
Well, I've seen in this on Valentine's Day that a lot of restaurants are trying. Unless 2 of them suck together and put it in another glass and suck, you can't drink, so they drink together. So they try to make friends. The restaurants are adding to a friendship.
Scores at this stage, J.C. Bose's team, 70 points. Unless they mess it up, they really can't do very much wrong from here. 20 points to the C.V. Raman team. Next question, again on the buzzer.
I have a color card here. On the left and right of my this black strip, there are colors. Okay. Do you see any difference in left and right?
Yes. No.
Okay. Now the question is, when I remove this black demarcation, do you find a difference now, left and right? Colors different between left and right of the line.
No.
You don't find a difference?
Yes, there is, but the pattern is similar.
No, no, I'm talking about difference of shade, color shade.
Difference of shade is there.
Color is same, but
Difference
intensity is different.
Yeah, intensity, color shade
Color
different.
is
Now the question is, when the demarcation line was not available, you could not notice the color shade difference. All right? Now when the demarcation line is open to you, you are able to see. Question is, why does it happen?
Yes, Wasim.
Yes.
When the black spot was there, we couldn't see the demarcation because there was the two colors, the two different colors was something apart, apart by a few centimeters. Hence, our visual perception cannot catch this because the intensity are coming less, and then gradually it comes up, and hence the contrast is not very much visible from this point when the black spot is there. But when it's removed, the two are meeting at just a line, and the two intensity are different in the two sides of that line, so it is quite visible then.
Well, a very nice attempt. I would like to give you 20 points for this, but I would like to add one more thing to this answer. As a visual perception, our eyes try to average out colors. If the average of the left hand side and average of the right hand side is same, that has been done in a computer. Gradation is this way and the gradation this way. The percentage of gradation, that is called vignetting, is same. So if the average of this and this one is same, and if the demarcation line is not available, you would see the same color. Exactly that's what happens when you look at a green lawn. The color of the lawn looks one, though the leaves are of different color. All right? Similarly, if you look at a plant, all leaves are not same color, same shade, but our eyes try to average out the color, and green, all the leaf looks of the similar color. Thank you.
Great answer there, Wasim. You pick up 20 points for your team. You move on to 40 points now, whereas the JC Bose team remains exactly where they were, 70 points. Last question, again on the buzzer.
Well, I have a toy here. These are 3 discs, but the diameter of the disc is different. I have to transfer this to either of the peg, but follow a rule that always the small has to remain on the top. For example, I'll do it for you. I have to transfer these 3 discs here, so I put this one here. 2 moves, then I put it back. This is the 3rd move. I now put it here. This is the 4th move. This is the 5th move, and this is the 6th move, and this is the 7th move. Now, I took 7 moves to transfer 3 discs from one peg to another, following the rule that always small will remain on the top. All right? Now the question is, if I have 5 discs or n number of discs, how many minimum moves I need to transfer them to another peg?
Hurry up, teams. 5 seconds to go. Yes, South Point.
Is it factorial n plus 1? Factorial n plus 1. I don't include the 1 in the factorial. N factorial plus 1. Not quite.
No, we don't have the right answer. JC Bose team, minus 10 for you. Anyone in the audience with an answer? You would like to try? Please come. What's your name?
Abhishek Haldar.
Okay, Abhishek, do you have an explanation?
Sir, is this 2n plus 1?
No.
Abhishek, we need you to answer the question, not ask them. Anybody in the audience? Nobody. You can go back. You guys don't have an explanation either, right?
n minus 1 p2.
Mr. Rautela, I guess you'll have to answer that one.
I
yourself.
would answer this for you. It's 2 to the power n minus 1. 2 to the power n full minus 1. It was 2 to the power 3, 8 minus 1, 7 moves. If I have 5, 2 to the power 5 minus 1, that will be 31. But it's very interesting question. This is called Brahma's tower.
Brahma's tower.
Yes.
Mr. Rautela, you're not getting mythological, are you?
Yes, there's a mathematical saying on this.
Okay, let's hear it.
There's a legend associated with this puzzle. According to Indian mythology, when Brahma was creating the universe, that's why it's called Brahma's tower. So Narad, you know Narad very well. He was disturbing him, asking him to make a better nose for this person or better eyes for this person. So Brahma was getting disturbed. So he gave this puzzle to Narad with 64 discs on this to transfer. And Narad could not finish this problem, though he knew the answer, till he could create the whole universe and the whole human beings or whatever it is according to mythology. Let me tell you, if there was 1 second per transfer, 2 to the power 64 minus 1 is equivalent to 10 to the power 56 years. And that's why Brahma could do it uninterrupted without disturbance of Narad.
I think that deserves that was a wonderful explanation,
Could you
Mr.
please explain
Rautela.
why this is 2 to the power n minus 1?
Okay.
Well, that's the formula works out. Suppose I do with 1. 2 to the power 1 minus 2 to the power 1 is 2, minus 1 is 1. So 1 move. If I have 2 discs here, for example, 1, 2, 3, 2 to the power 2 minus 1. So you derive the formula, it's very easy.
With that, we come to the end of today's episode. A full 100 points scored in today's episode. 60 points to the 𝐶𝐞𝐦𝐨 team. Well done, boys. Let's have a big round of applause for them. We have a small memento for you to carry home with you. Better luck, but equally well done. We hope you've enjoyed watching our show. You can write back to us with your comments to Quest, care of Doordarshan Kendra, Kolkata, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll see you again next week with 6 new faces, that's 2 new teams and 7 new questions. Till then, it's goodbye to you from the production team here in Doordarshan Kendra, Kolkata.